Lesson 4, Combinations. Number 1. If 5 sprinters compete in a race, how many different ways can the medals for first, second, and third place be awarded? We know how to do this. The 5 sprinters could come in first. Then we have a choice of 4 to come in second. And then the choice of 3 for third place. 5 times 4 times 3, which equals 60. Does the order matter here? Yes, it does. So this is an example of a permutation of 5 objects taken 3 at a time. Number 2. If 5 sprinters compete in a race and the fastest 3 qualify for the relay team, how many different relay teams can be formed? Visualize the 5 sprinters below. Since 3 will qualify for the relay team and 2 will not, consider the number of ways to arrange 3 Ys, the 3 that will run the relay, and 2 Ns for those that will not run in the relay. This looks like a permutation with like objects. So we have 5 factorial in the numerator, and 3 factorial for the ones that qualify, and 2 factorial for the 2 that don't qualify in the denominator. Does the order matter here? No, it does not. Now we'll define combinations. They are similar to permutations, but the main difference is that here order does not matter. So, an unordered selection of distinct objects is called a combination. The number of combinations of n distinct objects is NCR. Some like to say n combine R, or we can also say n choose R. The formula is n choose R equals n factorial divided by r factorial times n minus r factorial. Remember, there is also a button on your calculator that can do this for you. Let's look at an example, 1a. How many different committees of 3 people can be formed from 7 people? Order does not matter here. We just want a group of 3 people chosen from a group of 7. We use combinations. 7 choose 3. We can just use our calculators, or we can use the formula. 7C3 equals 7 factorial in the numerator and 3 factorial times 7 minus 3 factorial in the denominator, which is 7 factorial divided by 3 factorial, 4 factorial, which equals 35. Example 1b. How many different committees of 3 people can be formed from 7 people if the first person selected serves as the chairperson, the second as the treasurer, and the third as the secretary? Order now matters because the 3 positions determine specific titles. So we now use the permutation 7p3, which gives us 210 possibilities. You may notice, if we took the 35 possible committees from Part A and then order them, we would get 35 times 3 factorial. This would also give us 210. Example 1c. If the group of 7 people consists of 3 males and 4 females, how many different committees of 3 people can be formed with 1 male and 2 females? We must choose 1 male out of the group of 3 males and 2 females out of the group of 4 females. First, 3 choose 1 for the males times 4 choose 2 for the females. 3 times 6 is 18. The word "and" here implies times for these questions. 1 male and 2 females means to multiply the two quantities. Example 1D. If the group of 7 people consists of 3 males and 4 females as above, how many different committees of 3 people can be formed with at least 1 male on the committee? We can approach this in 2 different ways. First, we need at least 1 male, so we could have 1 male and 2 females, or 2 males and 1 female, or 3 males and no females. Here, we would calculate each of these 3 cases and then add the cases. The "or" implies adding. "And" means multiplying, "or" means add. We are going to approach this one in a different way. Think of this as being all of the possible committees except the committee with no males. This is considered the complement. We know the total number of committees is 35 from Part A. The number of committees with no males would be 3 choose 0 for the males and 4 choose 3 females, which is 4. The number of committees with at least 1 male would be 35 minus the 4, or 31. Example 2. A standard deck of 52 playing cards consists of 4 suits: spades, hearts, diamonds, and clubs, each with 13 cards. A. How many different 5-card hands can be formed? We have 52 cards and we want a hand of 5. Order does not matter, so we use 52 choose 5. We can put that in our calculators and we get 2,598,960. B. How many different 5-card hands can be formed that consists of all hearts? There are 13 hearts in a deck, so we are choosing 5 cards from those 13. 13 choose 5, which is 1,287. C. How many different 5-card hands can be formed that consist of all face cards? Face cards are jacks, queens, and kings, and there are 12 of them. So in this case, we would use 12 choose 5, which is equal to 792. Part B. How many different 5-card hands can be formed with 3 hearts and 2 spades? We need to choose 3 from the possible 13 hearts and 2 from the possible 13 spades. So 13 choose 3 times 13 choose 2, which is 287 times 78, which equals 22,308. Part E. How many different 5-card hands can be formed that consist of exactly 3 hearts? We need to choose 3 hearts from the 13 possible hearts, and for the remaining 2 cards, we need to choose from the non-hearts. Those are the spades, diamonds, and clubs. There are 39 of these. So, 13 choose 3 times 39 choose 2 equals 289 times 741, which gives us 211,926. Part F is a tricky one. We're going to have 3 cases here. How many different 5-card hands can be formed that consist of at least 3 hearts? We can have 3 hearts, 4 hearts, or 5 hearts. We figure each out separately. We already know that 3 hearts from part E would give us a total of 211,926 hands. For 4 hearts, we would have 13 choose 4 times 39 choose 1. This gives us a total of 27,885 hands. The last case of 5 hearts would be 13 choose 5 times 39 choose 0, which gives us 1,287. Since it is 3 or 4 or 5 hearts, we add the cases, and we get a total of 241,098.